Euclid's book 3, proposition 1 of elements talks of finding the center of the given circle. So the given circle is C, lowercase. So let's see what the construction involves. Let's mark 2 points A and B at random. This can be anywhere or this can be anywhere. We have to mark any 2 points. We join these 2 points. And now we bisect this. We know how to do that. Circles, circles, intersection, joining the intersections. Then the intersection of these 2 lines will give us the midpoint of AB, which is what bisecting a line means. Okay, so let's make these circles disappear. Now we mark the intersection of the circle with this line, but there are 2 intersections, one here and one here. So let's mark the other one as well. And now we join these 2 points of intersection so that we can make the line disappear. Now what do? Now we bisect CE, right? And we draw the perpendicular line. At the midpoint of C, again, we know how to do that. Let me make it smaller so that the whole thing is visible. Mark the points of intersection and join these points of intersection and make the circles disappear. Now let's just zoom in. Now the proposition says that this intersection of these 2 perpendicular lines is the center of the circle. But we have to prove that yes, it is actually the center. So again, we use the proof by contradiction. Let us say it is G which is the center and not F. Now we join AG, GD and GB. Now when we do this, we get 2 triangles. AD is equal to DB. Why? Because as part of construction, we bisected this line AB. So D is the midpoint. So which means AD is equal to BD. AG is equal to BG. Why? Because remember, we are assuming that G is the center of the circle. So which means these are the 2 radii of that circle. So that means these will be equal. And this is the common side. So that means these 2 triangles are congruent. Since these 2 triangles are congruent, that means this angle, that is GDA, is equal to angle BDG. Now again, this is a straight line standing on a straight line with the adjacent angles being equal to each other, because these 2 triangles are congruent. Since these 2 angles are equal, that means they are both right angles. But as part of a construction, we said DF is perpendicular to AB. That means BDF is also equal to 90 degree. So which means we are reaching a contradiction. We are saying BDF is equal to BDG and they both are right angles, which is not the case, because G, we chose a point away from F. It doesn't matter whether it is here or here or here or here, anywhere. It doesn't really matter. We will end up with the same contradiction. So that means G is not the center of the circle, and it doesn't matter where this G is, except when it is at F. That shows that it is F which is the center of the circle. So we have not only found the center, but we have also proved that that can be the only center of this circle. So that was proposition 1 of book 3 of Euclid's elements. Again, you can choose any random point B. You can choose any random point A. That F will not budge from that location. Again, let me remind you, there is a link to a PDF book which describes all these propositions with the constructions and proofs. You can download it, refer to it, and share it if you like. That's it for now.